Hi, folks. So I'm here to introduce you to a way to make a Rockin hypothesis. Hypothesis is something that's really tough for a lot of people to get, and it's one of those things that will make your life tons and tons and tons easier when you're doing science lab reports, trying to figure out an investigation to do in graduate school, all sorts of things. And this is a really quick, simple method to figure out your hypothesis. Okay, so the first thing, figure out your variables. What do you want in a test? So your dependent variable, what are you going to measure? So I'm going to give you some examples. Let's say you're going to test whether loud noises affect how fast a mouse's heartbeat is. Okay, so your variable for your dependent variable would be what you measure. And so that's going to be the mouse's heart rate. And your independent variable would be something like the level of noise, so the decibel level of a particular noise. Or you could say the tone of the noise. It just kind of depends on which way you go with it. Another example, and this is pulled from one of the classes that I teach, is density of candy bars. So you're figuring out introducing density. And so density is obviously what you're going to measure. So that'd be your dependent variable. And the independent variable could be anything about the candy bar. It could be the mass of the candy bar. It could be the number of ingredients or the types of ingredients in the candy bar. So let's just say the number of ingredients for argument's sake. So I'm going to use those two examples as we go through the rest of the thing. Mouse's heart rate versus noise, and the candy bar density versus number of ingredients. So let's move on to the next. So the next thing is the prediction. Now this is where people get confused because a lot of people think that a hypothesis is a prediction. It is and it isn't. And it's very difficult when you're introducing the concept of writing hypothesis to get those two separate. So your prediction is what do you think is going to happen? And it could be something as simple as there will be a change. There's also something called a null hypothesis where you say there will be no change or no effect. So for example, let's go to the mouse heart rate one. So the prediction would be the louder the noise is, the faster the mouse's heart rate is going to be because it's going to startle them. For the candy bar one, you could say the more ingredients a candy bar has, the more density it would have. That would be your prediction. So that's all great and good, and it's got your dependent and your independent variables in it, but it doesn't really leave you room to test anything. And the key definition for hypothesis is that it's an explanation that is testable. Keep that in mind. It is not an educated guess. I don't care how many times you were told to parrot that back to somebody. In the broadest logical sense of the word, it is an educated guess, but realistically, it's not a guess. It's an explanation you can test. And I really wish that elementary teachers would stop calling it an educated guess because it just leads to a lot of confusion and misconceptions later. But they do, so this is what we're dealing with now. Okay, so let's move on. After your prediction, you've got your variables. Now we're going to move on to what's your question. And so your question is really how do those two variables relate to each other? So your experimental question almost always, I mean, it gets fancier as you go into further areas of research, but really when you boil down every science experiment or investigation, it's really what's the effect of this thing on this other thing. And so in this case, it's what's the effect of your independent variable or the I changed it variable. Remember, it's something that you are manipulating on the dependent variable, something that depends on what you change. So in the two examples that I've been giving you, what is the effect of noise level on mouse heart rate? Make sure that it's a question, so you write a question mark at the end of that. Please don't write it as a sentence with a period at the end. Or what is the effect of ingredient number on candy bar density? So those are really simple statements, but realistically, that's what you're looking into in your experiment. It could be, what's the effect of the color of light on plant growth? It could be a lot of different things. Okay, so now we get down to the nitty gritty, and that's the hypothesis. And your hypothesis in almost all levels of science is in an if, then, and then sometimes an if, then, because format. So here's the really simple way of doing it. If you've identified your independent variable and your dependent variable, then you're ready to go. Because you say, if my independent variable does an action, then my dependent variable will do an action. And then sometimes you're asked to put in a because this is typically what happens or whatever. So here's your examples. So if noise level increases, then mouse heart rate should increase because, and you could go into neophobia and a whole lot of other things that are big fancy words for it scared them. Or if the candy bars contain more ingredients, or if the number of ingredients increases, then the density should increase because a larger number of ingredients packed into the same size space should have more density, or something along that line. You actually don't have to put a because for something as simple as that experiment, but that's kind of an example of how to go. Okay, so I hope that this helps you to really understand what an experimental hypothesis is. Make sure you've got some way of testing it kind of implied in your hypothesis. It has an independent variable and a dependent variable in it. And sometimes you need a because. So I hope that helps you out. This is just something kind of quick and easy for you to understand. And hopefully this will help you get better scores on lab reports wherever you may be. Blessings to you.